Every night, we look up and see it, a constant presence, the moon. It has been there for over 4 billion years, shaping our planet, our cultures, and even our biology. But what if one day it simply vanished? Not a gradual drift away, not a collision, just gone. Snapped out of existence. It sounds like science fiction, but asking this question isn't just an exercise in imagination. It's a way to understand just how much our world depends on that single seemingly ordinary rock in the sky. The moon affects everything from the tides to the length of our days, and even the stability of our climate. If it disappeared, the effects wouldn't be subtle. They would be catastrophic, and they would start immediately. Let's walk through what would happen, hour by hour, year by year, and discover why Earth without the moon would be a planet we barely recognize. Darkness and the tides. The disappearance would be instant. One moment the moon is there, the next it's not. The first thing people would notice is the sky. Half the world would be in darkness, but it's not the darkness of a new moon. It's the absence of the moon itself. Astronomers would be baffled, but within hours, something much more tangible would happen. The tides would begin to change. The moon's gravitational pull is the primary driver of ocean tides. The sun also contributes, but its effect is about half as strong. At the moment the moon vanishes, the tidal bulge that follows the moon would collapse. Coastal areas would see water levels drop or rise unpredictably. Within a day, the tidal rhythm we've known for millennia would be gone. Instead of 2 high and 2 low tides per day, we'd be left with only solar tides, much weaker, about 40% of the current tidal range. For coastal ecosystems that depend on tidal flows, mangroves, intertidal zones, spawning fish, this would be a sudden shock. But the most immediate danger would be for ships in harbors and people living in tidal basins. The sudden release of gravitational tension could trigger localized tsunamis as the water readjusts. The oceans wouldn't be calm, they'd be chaotic. The loss of a stabilizer. Now let's zoom out. The moon does more than just tug on our oceans. It acts as a gravitational anchor, stabilizing Earth's axial tilt. Currently, our planet spins with a tilt of about 23.5 degrees. That tilt gives us seasons. Without the moon, this tilt would begin to wobble. Over thousands of years, Earth's tilt could vary dramatically, from as low as 0 degrees to as high as 85 degrees. This isn't a sudden change. It would take tens of thousands of years to become extreme, but the consequences would be profound. A high tilt would mean extreme seasons, scorching summers and freezing winters with massive climate shifts. A low tilt would mean weak seasons, almost no variation throughout the year, which would disrupt agriculture and ecosystems adapted to seasonal cycles. Mars is a perfect example. Mars has 2 small moons, Phobos and Deimos, which are too tiny to stabilize its tilt. As a result, Mars wobbles chaotically over millions of years, and its climate has swung dramatically. Without the moon, Earth would eventually follow the same path. The stable climate that allowed civilization to develop would become a thing of the past. Slowing down without a break. Here's a less obvious effect. The moon is actually slowing down Earth's rotation. Through tidal friction, the moon gradually steals angular momentum, making our days longer. Currently, days lengthen by about 1.8 milliseconds per century. Without the moon, this braking effect would stop. But that's not the end of the story. Other factors would take over. The sun still exerts tides on Earth, and atmospheric effects would continue to alter our rotation. But the key point is that the day length would stabilize and eventually start changing in unpredictable ways. More importantly, the loss of the moon's gravitational influence could also affect Earth's core mantle coupling, possibly altering the planet's magnetic field over very long timescales. In the short term, we wouldn't notice a change in the length of a day. But over millions of years, the absence of the moon would mean no gradual slowdown. Days would remain shorter than they would have been, and the long-term evolution of Earth's rotation would be radically different. A cosmic loss. Beyond the physical effects, there's the cultural and biological impact. The moon is the brightest object in our night sky. Without it, the night would be significantly darker. Stars would appear sharper, and the Milky Way would be visible even from suburban areas. But that's a small consolation. For nocturnal animals that rely on moonlight for navigation, hunting, or avoiding predators, the sudden darkness would be disorienting. Many species, like sea turtles that use moonlight to find the ocean after hatching, would face immediate survival crises. Ecosystems would begin to unravel. And then there's the human element. The moon has been our calendar, our inspiration, our companion. Its disappearance would be a psychological shock. Every culture has stories tied to the moon. Losing it would be like losing a piece of our identity. The moon's remnant. Now, let's address a scientific nuance. The moon didn't just appear, it formed from a giant impact early in Earth's history. If it suddenly vanished, what would happen to the material that was once part of it? In a hypothetical poof scenario, the moon's mass is gone. But in reality, if it were destroyed by some cataclysm, the debris could form a ring around Earth, like Saturn's rings but much denser. A ring system would be beautiful, but it would also be dangerous. Debris would rain down on Earth over time, causing meteor showers and potential impacts. The sky would change dramatically, but the loss of the moon's gravitational influence would have already set irreversible changes in motion. The end of stability. As the axial tilt begins to wander over tens of thousands of years, the climate would enter a chaotic phase. Ice ages would become unpredictable. The equator might freeze while the poles become tropical. Life, which has evolved under relatively stable conditions for hundreds of millions of years, would face extreme selection pressures. Some species might adapt, but many would go extinct. Agriculture, which depends on predictable seasons, would become nearly impossible. Human civilization, as we know it, would be threatened. The great irony is that the moon, a barren rock, has been one of the key enablers of our existence. Without it, the stable Holocene epoch that allowed us to develop farming and cities might never have happened, or might end. Would we survive? So, what's the verdict? If the moon vanished today, would humanity survive? The immediate effects, tidal collapse and ecosystem disruption, would be serious, but they wouldn't wipe us out. We'd adapt to weaker tides, and we'd learn to navigate darker nights. The real danger is the long term. Over centuries and millennia, the loss of the moon's stabilizing influence would fundamentally alter our planet. Climate would become erratic. Seasons would become unpredictable. Earth would eventually resemble Mars in its chaotic axial wobble, making it far less hospitable. But here's the critical point. We are a technological species. We could potentially engineer solutions, giant mirrors to stabilize climate, orbital infrastructure to replace the moon's gravitational anchor, or even space habitats. But none of that is guaranteed. The loss of the moon would be a slow-motion catastrophe, unfolding over timescales that our current civilizations struggle to plan for. In the end, Earth would still be habitable in some sense, but it would be a different world, a harsher, less predictable one. The moon, it turns out, is not just a pretty face in the sky. It is our silent guardian. Appreciating what we have? We rarely think about the moon as essential to our survival. We see it, we romanticize it, but we take it for granted. Yet, without it, Earth would be a very different place. The tides would be weak, the nights would be dark, the seasons would go wild, and the very stability of our planet would be compromised. So the next time you look up and see the moon, whether it's a thin crescent or a full bright disk, remember that it's not just a satellite. It's our companion, our anchor, and perhaps one of the reasons we're here to ask questions like this. What would you miss most if the moon disappeared? Let me know in the comments. Thanks for watching Daily Dose of Space. Stay curious, and I'll see you tomorrow.